Hello everyone, let's solve this LeetCode problem number 107, binary tree level order traversal sequence second. Okay, so let's see the description of this problem. So given the root of a binary tree, return the bottom up level order traversal of its node's value from left to right, level by level, from leaf to root. So bottom up means like from the leaf to the root. Okay, and then also the direction from left to right. So that means we will return 15, 7, and then 9, 20, and 3. Okay, something like this. Okay, something like this. Okay, so this example. So how do we do? So we will use actually we are going to use a queue. Queue is the first in first out. So we will use a queue. First in, first out. Okay. So what we do here? So first, what we trying to do? We trying to offer the root to the queue. So in this one, the root is a 3, and then after we offer 3 to the root. After we offer the root to the queue, what we do, we will check the queue is empty or no. So the queue is not empty, so we declare the size of the queue. So in this case is 1. Okay, and then we will new a level. So that means in this level, we have one element. The size of this level is 1. Okay, we only have one element here. Okay, so and then we will iterate every single element from this level. So in this case, this level only have 1. So first, what we do, we pull the 3 out from the queue, and then we add it to the level. And then we will check this one have left child, or if we will check if we have left child. In this case, yes, have left child. So we will offer the none to the queue. And then we will check the root have a right child or no. So in this case, we have right child. So we will offer it to here. Okay. And then after this, what we do, we will continue check if this queue is 0 or no. So in this case, it's not 0. No, it's empty or no. So in this case, it's not empty. So what we do, we will check the size of in this level is 2. Okay. After we check the size is 2, so we will pull twice. Okay. So first we will pull 9 out. After we pull 9 out, we will check. We will add the 9 to our level. Our level, this one says is 2, okay? So, and then first we will add 9 to the level, and then we will check the 9 have left child or right child. In this case, they don't have a left child or right child, and then we will pull the 20 out. We will check 20 have left child or right child. So they do have a left child. After we pull, we put it to our level, and then they do have a left child and a right child, so we just add it to our queue. Okay, this is another level. And then after we pull everything from this level, so what we do, we just copy this part. Actually, we have result. So the result is like this. So first level, after we finish iterating the 3, we copy the 3 to our result. And now we finish the second level. So what we do, we copy this one to the front of this linked list. Okay, so what we do this way. Okay, so because we are using the linked list, we just actually add this level to the front. Okay, so we use ON. The temp complicity. But if we are not using linked list, it's gonna take, if we use an array list, let's say, so it's gonna take ON, because after we added the front, and then this one we have to move this way, right? So it really take time. So that's why here when we're trying to survey, we use a linked list. Okay, and then we will check the queue is empty or no. So in this case, it's not empty. The size here is 2. Okay, so and then we pull the 15 out, and then we add the new level is 15, and then we check 15 have left child or right child. It's not, and then we will pull the 7 out. After we pull the 7 out, we will check 7 have left child or right child. They don't have it, so we add it to the level here, and then we add this one to the linked list here. Okay, yeah, this is our result, and then we just return. Okay, this is basically the algorithm. Okay, so let's start coding. So what we do here, first we will define the linked list. Okay, it's a list of integer. Okay, is result. Linked list. Okay, after we do this, we will check if root equals to none. If equals to none, what we do, we just return result. Okay, it's gonna be empty. Okay, and then we are using the queue, the tree node. Okay, inside the queue is tree node. That's our tab, the data tab. And then the name is queue, and then we are using array back here. Okay, and then we will offer the root to the queue. After we offer the root to the queue, and what we do, we will check if the queue is empty or no. So of course we just it's not empty because we just offer the root to here. So the first level we are checking the root is empty or no. Here it's not empty. So what we do, we will, given the size of the queue, because this is the level, in this level, how many tree nodes in this level? So in this case, in the root, it's gonna be just 1. And then we will new a level, integer. We have level here. And then what we do, this is a level. And then what we do, we just do the array list. And then what we do for loop, int I equals to 0, I smaller than size, and I plus plus. And then what we do, the tree node is gonna be node equals to queue there dot pull. We will pull this out, and the level dot add node dot value. Okay, and then we will check the left child is not equals to none. If it's not equals to none, what we do, we will queue the offer node left. Okay, and then we will check node right not equals to none. Okay, this one is right. Result dot add first. Okay, we are going to add first using the linked list because we are doing bottom to up, right? So we just added. So first, the first level we did 3, and then when we traverse the second level, we add front of 3, and then we add the last level in front of the middle level. So our result is going to be this. Okay, it's very similar with the up to bottom, left to right. Okay, so the time complexity will be same as the binary tree level order traversal. Let's run this code. Okay, here. Yes, here we need to return, okay? So what we do, we just add this one to there. We have to return the result, okay? Run the code and then we will return. Okay, accept. Let's submit the code. Okay, let's talk about the time complexity for this problem. For this problem, the time complexity is going to be ON because we traversal everything go 3 nodes just once. Okay, it's ON. Okay, so we have N nodes. Okay, the space complexity. The space complexity will W. Okay, so that's the max of it's gonna be the max of level the max length of the level. Okay, yeah. Because here we have extra space to save the level, the result of the level here. Which one we use? Oh yeah, here. So we use the extra space to save this one, and then we will copy this one to our final result. So the space complexity will be size of this one. So it will be the maximum of the length of the level. So for some tree, oh, not that one. Okay, so for some tree, let's say this one is gonna be 2. If this one is a complicated tree here, if we have 4, so our space complexity here, the level will be 4. So that's why it's OW. Okay. Thank you for watching. I'll see you next time.